Okay, so there's I think I got it wrong last time. So it's not like your branches are not interfering with each other. Like that doesn't make sense actually. It doesn't make sense because I mean they're separate branches, right? Like so they're actually, coupled to a particular value of another qubit, and so those branches won't, like, unless the branches become equal, and then they would naturally merge, and so you don't have branches anymore. It kind of feels like they shouldn't, like there's no, it's not about interference between branches. And so I kind of like trying to go a little bit back, like one step back, when I was saying about, like, okay, let's think about entanglement as this sort of different types of, like, computational branches that you can create with control gates. And I was looking for an example the other day where you would get a how's it called, like a non-maximum entangled state. Because if you have a qubit in the plus state, and then you have another qubit on the zero state, for example, and you apply a control knot, then you basically get the one of the Bell states, which is kind of a maximum entangled state. If you have, say, a qubit in the plus state and another qubit in the plus state, or even in the minus state, the control knot won't really create two different branches, right? Because even in the case where you have the second qubit, the target qubit is in the minus state, and you apply a control knot, like, you will of course change the 0 for a 1 and the 1 for a 0, but, like, the relative phase stays the same, like in the other branch. So it's all like a 180 degrees relative phase between the two different states in each branch. And so that makes the branches equal, and so there's no branch, and so there's no entanglement. What makes sense is that when there's branches, then there's entanglement, some sort of. I think I can still say that. Now, I was playing with Quirk the other day, and I realized that one way to create like non-maximum entangled states is when you, instead of, like, so if you have like a 2 qubits in the plus state and you apply a controlled Z, then you're basically, maybe not a control Z, like, if you apply a control Z, then you're creating again a maximum entangled a maximally entangled state, I think so, right? Because they're creating essentially two branches. One is in the plus state and one is in the minus state, and those are maximum entangled. And if you apply instead of a Z, like a control Z, like a controlled Z to the power of, like, a half, so like a square root of Z, or like an S, like, like a controlled S, then you get a, like, half entangled state. Half in the sense that, like, if you take a look at a Bloch sphere, the point will be halfway to the center of the sphere, so not in the complete center. And that's puzzling, because so it seems like if the branches are completely opposite or completely different from a phase perspective, maybe, at least based on this example, then you've got, like, a maximum entanglement. If they're not, like, opposite, because here you have, like, a phase of, like, 90 degrees in one of the branches, and a relative phase of 0 degrees, so no relative phase in another branch, and that gives you a half entangled state. But I'm far from. So why would these be? How? I don't know. I'm so stuck. I'm really so stuck here. Like, what makes this different than the other option where you have like an opposite like relative phase between branches? Like, it seems it's a notion of how different the branches are. Like, it almost looks like, if you think of those branches as, kind of vectors or whatnot. Like, I mean, the difference is just, they would be maybe orthogonal or something like this. But I'm not happy with this explanation. I want to have something be more intuitive. And why is that? Like, is that useful at all? Knowing this difference? Does this make the entangled state for some reason more powerful or less powerful? This is, I gotta dig into this, but I think I can't do this just in my head. I think I have to get my hands on Quirk or something to play with these. But definitely that's one of those one of the differences here. So you basically have these two branches where they're not completely opposites. And so, but what does this mean? Okay, so let's say one branch is in the 0 plus I1 state, and another branch is in the 0 plus 1 state. Okay, so maybe there is indeed something with interference in here, as in, like, if these branches were to interfere, like in the case where there's maximum entanglement, when the branches if you try to think of the branches interfering, you get nothing, right? Like, because you have like a 0 plus 1 and 0 minus 1. Oh, the other way around. You have no branches at all. Like, you just have like a 0 state or something if it's maximally entangled. So, okay. You go back to it's like almost if you would interfere them, they're like kind of going cleanly back to 0. But I don't know how to define that a bit better, because in the case where there's no entanglement, the branches are equal, and so the branches are equal. This means there's no interference at all, right? And so you're left with the same state like that each branch represents. If the relative phases are opposite, then you do see some interference, right? For example, if you've got like 0 plus 1, 0 minus 1. So you would see some interference between the plus 1 and the minus 1, and you would kind of end up with 0. So it's like there's no superposition anymore, right? But in the case with this maximum entanglement, like if you have a 0 plus I1 and 0 plus 1, like this I1 and plus 1, like they'll actually constructively interfere, right? Like this would become a 1 plus I, right? You can do that, right? Because it's a real part and the complex part. I think you can just add them up like this, yeah. It's like removing the one as sort of a common factor. And so you would have actually constructive interference in there. So when there's constructive interference in between the computational branches, or there would be, maybe there is, I don't know, is there? I don't know. That's kind of when you have non-maximum entanglement, because it means that it has something to do with that there's something else. It's not everything in the branches, because I think that's the definition, right? Like, it's not everything in this across the state. Like, I gotta think about this a little bit more. Definitely gotta think about this a bit more.